Well, hello everybody, and here we go with something new. This is a very nice Harman Kardon AM/FM receiver from, I guess, sometime in the 60s, I would guess. And good for me, I have the schematic here. There it is. And this poor guy is just not working properly. Let's hook him up. Get him going. Got to put a speaker on it. Normally I would tin these wires, they're a little easier to work with, but the soldering iron's just warming up, so I'm not going to bother. Just hook them into the speaker here. So there they are in the back of the speaker now. My little teeny speaker. And we'll put these wires on the back, on the output terminals. Now, although this is an FM receiver, it can't do anything with a stereo signal. It's a mono receiver. So it only takes one speaker. There we go. Excuse me, ouch. And no antenna on it right now. I can't expect it to work too well the way it is. But let's start it up. See what we get. Okay, so the information I'm starting with is no tuner, amp OK question mark. So this guy's not working, and nobody really knows why. So just a quick look around before I switch on the power, and everything looks quite fine. There's the on-off, tuning. And two more controls. Oh, I bet you it's bass and treble. Put them about mid-band. There is a plate that goes on here, and I don't have the plate because the plate, which is very decorative, is in absolutely perfect condition. It looked like it was just came out of a box. So that plate is away. It's protected somewhere where there's no way it's going to get damaged while the rest of the unit's being worked on. But consequently, a lot of the name of the dials are gone, and these buttons are gone. So, I have to use my memory on this to know which button is pushed where. So I think we're all set here. We'll go on current limiting, supply voltage 124. There we go. You can see my light bulb back here is glowing. Looks brighter in the camera than it looks with my own eyes. But there's a pretty good draw. Now, before I brought this to my home shop, I did work on it in the commercial shop that I'm in one day a week. And I discovered that the rectifier tube was shorted. So we got that out of there. So we have a good rectifier tube. And I did not test. I tested a few of the other tubes, the 2 output tubes. And I think that's about all I got done. So nothing funny happening. Let's put it on full voltage here. There we go. Okay, there's a buzz coming out of the speaker. Well, I could be on FM or AM right now. That's louder. I think this is AM. Lots of noise coming out of there. It's got 2 more inputs on the back. What are those? Well, let's take a look. Phono and auxiliary. Okay, so that explains the 4 buttons. AM, FM, phono, and auxiliary. Turn the volume down and get our little screwdriver out. We can probably figure out which is which back here. Okay. So that's phono. The way I remembered to be phono and auxiliary out here. Let's try that. We'll put what I think is auxiliary. Sure enough. So it's phono, AM, FM, auxiliary. So go back to AM. Doesn't really sound any different than the those are a little different. We're going to have to put an antenna on there. And see what that does for us. It smells pretty hot. It smells like a hot guy. Now, maybe it just hasn't been operated for a long time. But, there's a lot of heat coming off these 2 tubes here. Oh my gosh. There's a... You know, the other rectifier had a blue glow all over the top of it. So, you know, there could be something very bad with these output tubes here. Really drawing the, because they are hot. Wow. Now maybe we'll knock it down to current limiting while we're carrying on with this. Just in case there's something a little more wrong here than I realize. Because what could be happening is there could be a problem with the biasing of the output tubes, and they could be sitting there conducting a heavy current, and the evidence of that would be they get pretty hot. In the worst case, they get red hot. And I've never actually seen them get red hot, but I've certainly heard stories. So we don't want to damage them. But that is just whipping up the heat there. Wow. That would feel similar to putting your hand over a 100-watt incandescent light. That just seems to me to be way too much. Okay, so I have the antenna connected. We better plug it in. We'll plug it into the external house antenna. See what we get. Yeah, don't get anything. I think I put it on the FM side. We're getting nothing. We're also, there's a magic eye on this radio, and it's doing nothing also. So I have the feeling there's no B plus happening here. No B plus. So what we'll do is we'll verify the B plus. And I'm going to do that by pulling out a tube. Eeny, meeny, miny, mo. This one here, it must go. Okay, with the volume turned down, I'm pulling out what I already know is a 6BE6, which is the converter mixer tube. And I'm just going to go around the pins and check the voltage that's on the pins there. Make sure you can see that. There we go. I'm on the 200 volt scale. Just to the chassis. Pin number 1. 2. 3. 3 of them zeros. 4. 5. What's going on here? 6. 7. Hey, there's nothing. Nothing at all there. Nothing at all. Did I do that right? He says full of self-doubt. Let's check it again here. That's 7, 6, 5, 4. Damn, they're all 0. Okay. Well, it would appear that there's no B plus. Let's feed an audio signal into the audio amp at the back. Oh. I have to get my handy dandy radio, which I was listening to during the big blackout this morning. So I'll be right back. Okay, so I like to use this radio as an input. It's a very handy little radio. And because it's battery operated, the way it is right now, I don't have to worry about some kind of crazy grounding situation. So we'll put that in the auxiliary. Put on the auxiliary button. Put on the radio.
Every citizen in this country.
Turn that down. Turn this up.
Equal representation of their choice in the Parliament of Canada. And there's only one way to do that. That's to change the voting system to equal effective vote, proportional representation.
Our question, when have you felt like politicians were shopping for your vote? 1-817-8995.
Okay, well, we know, this is odd, we know the output stage is working. And, you know, in most power supplies, the output stage is fed from, I don't know how to put this, the earlier part of the power supply, the slightly later part of the power supply, which is better filtered, is then fed out to the rest of the radio where hum sensitivity is much higher. And in between those two parts, there's often a resistor, and that resistor often burns out. So that's my guess. Let's see if I'm right. So we'll shut it off, shut the power off, and we'll flip this guy over. It's good. And we will look underneath it for a great big honkin' resistor. Ooh, there's one. 20 watt. That's a really big honkin' resistor. Wow. So that's probably the one I'm talking about. Ooh, she's as hot as can be. So I don't think that's burned out. Phooey on my theory. Could have gone high, restricting the voltage. The voltage could be pulled down beyond this by a short circuit. A short circuit could be in the big power supply capacitor itself, or could be at any one of a number of capacitors that are connected to the high voltage. Now, we have to turn the set back on and do some voltage tests on either side of this resistor, and even read the resistance of the resistor. I see another part that looks a little cooked up right in there. Here, let's take a closer look. Take it easy with my camera. It looks like when you change its position dramatically, the automatic focus doesn't go. Hey, look. Down here is another great big resistor, and what's it connected to? It's connected to nothing. It's been cut away. So this is probably the original resistor. Here, I mean, certainly it is. Trying to read the resistance on it. I can't quite see it there. I can see a number there, 495 something or other. So this is probably the replacement for this. 4K ohms. That's pretty high resistance. Okay. And there's the part that looks a little cooked up. Right dead center in the screen there. Doesn't mean it is. And here's another one that doesn't. What's that? It's just got wax. It's had wax flow onto him from the capacitor above. It's another radio with the parts all over the place here. I mean, it's a bit of a rat's nest. It's not particularly dirty under here. Well, I think we need to investigate what's going on with the power supply and chase it down. Let's take a look at the schematic here for a minute. So let's become familiar with the power supply circuitry. There it is. Typical full wave center tapped power supply, 335 volts AC being applied to it, so I'll bet you this thing develops around 300 volts. There's the first capacitor there, 20 microfarads. So let's continue it on this page here. Oh, it's actually got them written 270, 245, 160, and 150. Wow. So there's 4 different outputs on here. How did they do that? Well, part of it is a great big resistor, 4700 ohm resistor. And that would be that guy. The 4, supposed to be 47, they got a 4000 in there. So that could be original. No, what am I saying? This is the original one down here. So this is probably 47. And somebody put in a 4K thinking, it doesn't make much difference. And you know, they're probably right. So, man, you really got to stare at this carefully. Nothing particularly surprising, but we should be able to find all these voltages. 150, 160, 245, and 270. So let's start there. Okay, a little safety check. All is good. Ready for powering up. Power up. And I'm going to power it up still on current restriction, because I don't know what's going on yet. See that. And the 200 volt scale should blow it off. Let's check the resistance of this supposedly defective resistor. $18K. So it's gone high. So this one went high. Now we'll check the. Oh, I already turned the set on. Duh. Can't check this. So we'll go back to voltages. I should have checked that resistor before turning the set on. Okay, we're on the 1000 volt scale. One side of the resistor. Nothing? Well, the other side. Yeah, what's that telling you, man? Something bad there. Yikes. What's coming right off the rectifier tube? $90. $90? Come on, that can't be good. And you know what? That tube is glowing blue inside. I think we got a real short on our hands here. This is the filter capacitor. It's a 0. 90. Okay, so what we're going to do is we're going to shut it off. I think we have a short on the high voltage. We're getting 90 volts to the output tubes. That's enough to make them operate. But obviously that should really be something like almost 300. Now I was on current restriction and the bulb was glowing fairly bright. I didn't notice the supply voltage percentage, but I'll bet you it was down around 75 to 80 volts. And all that's indicating a heavy current drain, heavier than I would expect for something of this size. So it's all adding up to, whoa baby, there's a short in this set somewhere. Now, I'm going to put this to resistance again, and we'll read the resistance to ground on the side of the resistor we were getting a 0 on. Come on. 0. So somewhere down the line, so I see there's two wires coming off that terminal. One goes to the capacitor, just as you would expect. I'm going to open that wire. He says, making sure things are turned off. We'll open that wire. Pretty long wire, eh? Look at how long this wire is. Kind of funny. I wonder why they did that. Yeah. A surplus in wire that day? What would that be from? Come on off of there. Okay, there it is. It's off. Now I'll measure the resistance to ground again. Now it's, you know, some hundreds. It's 120 K, and the end of this wire. Come on, man, it's showing a high resistance too. I think there's some voltage on there. Not really. Hey, you know what? I'm reading the same thing there, aren't I? Duh. I'm just reading either end of the same wire. Let's try that again. That's why we're getting similar readings, of course. 150. Then it's got to be the same. It's the same point. 130. It's this one I want to check for 0. 0. I'll now lift the next wire off, and we'll either discover that it's the filter capacitor is a complete short, or the problem lies further on. Wrong pliers. Hey, where can my pliers go? They can't go very far. Oh, they're in my hand. Okay. Almost time to stop for lunch, I think. Gotta recharge my batteries here. That wire's off. Here we go. Drum roll, please. If we see a short circuit, we'll know the problem. Here we go. Short. What about the other side? The other side seems fine. There's a short right there. What about this part here? He seems fine too. So that guy is shorted. He's a shorted. You know, that could be why the rectifier tube was shot, the original one, because the set was left operating full tilt too long in this mode. The excess current did away with the rectifier tube. It was glowing. I wish I'd had a video to take a shot of it. It was glowing blue. A little scary to see, because I think that blue light might be emitting significant ultraviolet light. I'm not sure. So as soon as we noticed it, as soon as I noticed it, because, you know, you got to envision this. I'm working in a shop with a couple other guys, and whenever we find something unusual, we call, hey, come on over and see this. So we're all gawking at it there, and then we turn the power off to it. Because I'd never seen a tube actually glow blue like that before. So this is going to be is on the far side of the 470 resistor. The far side. Hey, you just. Whoa. I gotta stop you. I gotta figure out a better way to run these wires in the shop because I keep sending you guys for quite a ride. That was all the way down to the floor that time. Right. It's a. Oh, it looks like a. No, it's a 20. It's a 20, and that 90 volts should actually have been 270 volts. And 20. So now normally these big capacitors, the big metal can capacitors, they don't usually develop a short. They're more likely to just lose their capacity as they dry out. This one's actually got a short on it. And there's two repair techniques for these guys when you come across the capacitors. If they're not shorted, they you can just parallel in new capacitance and carry on. The risk is the old capacitor will short out at some point. The benefit is you have these terminals, all the wires, and everything's right there where it needs to be. It's real easy to pop in some extra capacitance. Now, if you don't want to do that, if you want to get off this old capacitor completely for fear that it's going to develop a short, then you have a problem. There are no terminals to work with other than the ones right on the capacitor. Now this leads to a messy situation. If you can either make all the connections airborne and just leave them in the radio kind of floating around, which is not very good, or you can mount in a connector strip. In this radio there's lots of room. I could actually mount one in here somewhere, probably. A terminal strip. The difficulty of that is the wires won't reach to it. So everything will have to be extended and fiddled mightily. Now in this case, I got all this wire here, and this is fairly substantial. So I should be able to find a very good ground point. Look, there's one right here. And to just solder in my replacement capacitor. And you know what? It's going to have, if I can get it soldered onto here, it's going to have enough mechanical strength to be its own terminal from there. So that's the approach we will take. Let's see, on the clock. Yeah, time for me to take a little break here. I think eat some lunch. We'll come back. We'll solder in that new capacitor and see if this whole thing doesn't just come right back to life at that point. Yeah. Hey, now's a good time to check the resistance of this. Let's do that. And then I'm off to eat some lunch. Okay, so we're looking for 4K on the meter. It certainly is a big honker. Yeah, 4K, right on the money. So the capacitors, so the resistor's good. So that's good. That's all for now, and we'll see you in a little bit, which to you will seem like microseconds.